Good day. In this video, I'll show you how to derive the quadratic formula. By the way, if you haven't watched my video about the quadratic equation, please watch it first, so you will have an idea about the quadratic equation, and why do we need the quadratic formula. I have added the link of that video in the description section. If you already watched the video, let's start our discussion. Are you one of those who wonder where the famous quadratic formula came from? It was derived from the general form of the quadratic equation, using the completing the square method. In my previous video, we have already discussed the quadratic equation and the step-by-step method, on how to get the solutions by completing the square. Now, let's try to use the completing the square method, to find the solutions of this general form of quadratic equation. Step 1, simplify the equation by dividing all the terms by the quadratic coefficient. By doing that, our equation will now become x squared plus b over ax plus c over a is equal to 0. Step 2, using the simplified equation, move the constant to the right-hand side of the equation. Our equation will now become x squared plus b over ax equals negative c over a. Step 3, complete the square of the left-hand side of the equation. Our aim is to make this equation a perfect square. As what we have discussed on previous video, to make this a perfect square, we need to add the missing piece. Remember, whatever we will do to the left-hand side of the equation, we also need to do it in the right-hand side. That is called balancing the equation. Let's say the missing piece will be represented by d. We need to add d to both sides of the equation. We learned from previous video, that to make this equation a perfect square, the value of d should be b squared over 4a. Where b is our linear coefficient and a is the quadratic coefficient. From our equation, our linear coefficient is b over a, and our quadratic coefficient is 1. Take note, when there is no coefficient beside the variable, there is always an invisible 1 in there. Since we now know the value of a and b, let's substitute those, to get the value of d. The value of d then becomes b over a squared, divided by 4 times 1. Or simply, the quantity, b over 2a squared. Our equation will now become x squared, plus b over ax, plus b over 2a squared, equals negative c over a, plus b over 2a squared. This equation is now a perfect square. We can now write our equation as the quantity x, plus b over 2a squared, equals negative c over a, plus b squared, over 4a squared. Let's now work in adding these fractions. It will result to 2ax, plus b, all over 2a squared, equals the quantity negative 4ac, plus b squared, all over 4a squared. This term can be simplified by squaring the numerator, and squaring the denominator. Thus, it can be written as 2ax, plus b squared, divided by 4a squared. The other side of the equation can be written as b squared, minus 4ac, all over 4a squared. From here, we can cancel out 4a squared, from both sides of the equations. And we are now ready for step 4. Which is to take the square root of both sides of the equations. The equation will now become 2ax, plus b, equals the square root of b squared, minus 4ac. Take note that for us to have a real solution, this term should be positive. And a positive number has 2 square roots. Same value but with different sign. One is positive and the other one is negative. That is why we will have the plus and minus sign in front of the radical. Now, we are ready for the 5th and final step, which is to solve for the value of x. From our equation, 2ax is equal to negative b, plus or minus the square root of b squared, minus 4ac. And from there, x is equal to negative b, plus or minus the square root of b squared, minus 4ac, all over 2a. And here is the famous quadratic formula. Thank you for watching. I hope you learned something from this video. Please don't forget to click the like button, share, and subscribe to this channel. Appreciate it.